students. The first video we have seen that how to find the adjoint and inverse of 2 by 2 and 3 by 3 matrix. In this video we are going to start our first exercise. So the first one, find the adjoint of the matrix A minus 3 4 6 2. Your answer is your adjoint of A is nothing but interchanging the diagonal elements 2 and minus 3, and these two number you have to change the sign, minus 4 and minus 6. This is 1 mark question. Okay, that's it. And number 2, 3 by 3 matrix. Your A is 2 3 1 3 4 1 3 7 2. So we are going to follow the second method for finding the adjoint using 4 minor method 2 for your adjoint. You write the matrix 2 times, 2 3 1 3 4 1 3 7 2, and again A is 2 3 1 3 4 1 3 7 2. So what is the second method? We are going to follow 4 minus number 1, number 2, number 3, number 4. So for finding cofactor, your Aij is nothing but cofactor matrix. I circled 4 numbers, right? So that 4 minus only we are going to follow. The first one, this, that is 4 1 7 2. The second one, minor of this one, so that is 3 4 3 7. So what I am doing is the 2 minor 4 1 7 2, your first 4 entries, and the 1 minor is 3 4 3 7, this second 4 numbers, and here the minor of 3 is this 4 numbers. So that is our next row. It is 3 1 4 1, and again for 2 we have to follow these 4 numbers. So it is 2 3 3 4. So what we are going to do is very simple. This two product 8 minus 7. Next to this two product is 3 minus 6. Next to this two product is 21 minus 12. Again here it is 7 minus 6, 4 minus 3, and 9 minus 14. And next this one becomes 3 minus 4, and again it is 3 minus 2, and it is 8 minus 9. So instead of doing A11, A12, A13, A21, A22, A23, you can follow like this. This is a simple method. Your numbers are 1 minus 3, 9, and 1, 1, minus 5, minus 1, 1, minus 1. So we found a cofactor matrix. Adjoint of A is nothing but Aij transpose So this matrix transpose become 1, 1, minus 1, minus 3, 1, 1, 9, minus 5, minus 1. So we found out the adjoint of matrix. So it is very easy method to find the adjoint of 3 by 3 matrix. Now your second question, find the inverse of the matrix. The first one, A is minus 2, 4, 1, minus 3. It's 2 by 2, so easily we can find out the answer. Our solution is, first we need the determinant. Determinant of A is equal to minus 2, 4, 1, minus 3. It is nothing but 6 minus 4. This two product minus this two product. 6 minus 4 is 2, is not equal to 0. Therefore, A inverse exits. Next we need adjoint of A. So adjoint of A is nothing but interchanging the diagonal elements, minus 3, minus 2, changing the sign of these two numbers, minus 4, minus 1. So we got the adjoint of A. Therefore, A inverse is nothing but 1 by determinant of A into adjoint of A. Your formula is 1 by 2 into adjoint is minus 3, minus 4, minus 1, minus 2. That's it. This is your inverse of 2 by 2 matrix. Now the inverse of 3 by 3 matrix. Our A is 5, 1, 1, 1, 5, 1, 1, 1, 5. So what is our determinant of A? Determinant of A is 5, 1, 1, 1, 5, 1, 1, 1, 5. This is 3 by 3 matrix. So we have to do for the first row, 5 minor is this 4 numbers, 5, 1, 1, 5. Minus of 1 into eliminating first row, second column, 1, 1, 1, 5. 1, 1, 1, 5 plus 1 into minor of this number. So eliminating the first row and third column, it is 1, 5, 1, 1. So it becomes 5 into 25 minus 1, minus 1 into 5 minus 1, plus 1 into 1 minus 5. It is 5 into 24 minus 1 into 4 plus 1 into minus 4. So that is 120 minus 4 is 120 minus 8 is 112. Is not equal to 0. Therefore, A inverse exits. So for all the question, we need the determinant first. Suppose the determinant equal to 0 means A inverse does not exit. You no need to go for the adjoint. But here it is not equal to 0. A inverse exits. We have to find the cofactor matrix, where Aij is found out by that minor 4 corner method. So we can write A 2 times first, where A is 5, 1, 1, 1, 5, 1, 1, 1, 5. 2 times you write 5, 1, 1, 1, 5, 1, 1, 1, 5. So you can use 2 numbers, 2 letters, 2 colors, 2 numbers. So these are the 4 minus we are using. So Aij is nothing but 5 minus are 5, 1, 1, 5, and 1 minor 1, 5, 1, 1, and this minor is 1, 1, 5, 1, and 5 minor of this 5 is 5, 1, 1, 5. So the answer will be again these two product. 25 minus 1 is your first number. Then again 1 minus 5, second number. Third number will be 1 minus 5. And here it is then 1 minus 5, 25 minus 1, 1 minus 5. The third row will be 1 minus 5, 1 minus 5, 25 minus 1. So that is nothing but 25 minus 1, 24 minus 4 minus 4 minus 4, 24 minus 4 minus 4 minus 4, 24. This is our cofactor matrix. Therefore, adjoint of A is nothing but the same matrix. It is 24 minus 4 minus 4 minus 4, 24 minus 4 minus 4 minus 4, 24. No change in our transpose. Therefore, A inverse, again we will write the formula 1 pi determinant of A into adjoint of A is nothing but 1 pi 112. Your determinant of A is 112, 24 minus 4 minus 4 minus 4, 24 minus 4 minus 4 minus 4, 24. So inside 4 is a common factor. So we can take 4 as common factor. It will become, the matrix is 6 minus 1 minus 1 minus 1 6 minus 1 minus 1 minus 1 6. The 4 and 112 we can cancel. It becomes 1 pi 28 of 6 minus 1 minus 1 minus 1 6 minus 1 minus 1 minus 1 6. So your answer is 1 pi 28 into the matrix. It's clear. So you can practice with this same question 2 times. The next one will be the third question. Our third question is very simple. If f of alpha is nothing but cos alpha 0 sin alpha and 0 1 0 minus sin alpha 0 cos alpha, you have to show that f of alpha inverse is nothing but f of minus alpha. So the question itself you have the answer. So what you have to prove? F of minus alpha is nothing but f of alpha inverse. So first we will find out the f of minus alpha. F of minus alpha, what you have to do is wherever alpha replaced by minus alpha. So cos of minus alpha 0, sin of minus alpha and 0 1 0 minus of sin into minus alpha 0 cos of minus alpha. Your cos is even function, so this minus we can cancel. Sin is odd function, this minus will come front, it becomes minus of sin alpha, and sin is odd function, minus into minus you will get plus. Again cos is even function, you will get plus cos alpha. This is nothing but cos alpha 0 minus sin alpha. Again 0 1 0 no change, it becomes sin alpha 0 cos alpha. So we found out the RHS, that is number 1. This is number 1. Number 2, we will write f of alpha again, where f of alpha is cos alpha 0 minus sin alpha and 0 sin alpha 1 0 0 cos alpha. We have to find the cofactor matrix. So that is, we call it as again A. So your Aij is nothing but minor of cos alpha is 1 0 0 cos alpha, and minor of sin alpha is 0, 1, minus sin alpha 0, and minor of again minus sin alpha is 0, sin alpha and 1, 0, and minor of cos alpha is cos alpha 0, 0, 1. So we are taking the minor, you have the underline, that minus only we are taking. The product is again cos alpha minus 0, and this becomes 0 minus 0. The third number becomes 0 plus sin alpha. It's nothing but determinant expansion. Already you have one minus sign, so you will get plus sign. And the second one becomes 0 minus 0, and this is cos square alpha plus sin square alpha. And the third one becomes 0 minus 0, and here 0 minus sin alpha and 0 minus 0 and cos alpha. So we found out Aij cofactor matrix. Once again we will rewrite cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. So this is our cofactor matrix. So what is our adjoint of f of alpha? Is nothing but adjoint of A, that is nothing but Aij transpose. Aij transpose, that becomes the transpose of this one. This sin alpha will come here, this minus sin alpha here, that's it. Cos alpha 0 minus sin alpha 0 1 0, no change. This becomes sin alpha 0 cos alpha. So this is our adjoint of f of alpha. Now the determinant of f of alpha, determinant of f of alpha is nothing but determinant of cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. So the answer is cos alpha, the minor is 1 0 0 cos alpha and minus 0, so no need to write the minor, plus sin alpha of 0 1 minus sin alpha 0. The expansion cos alpha into cos alpha minus 0 plus sin alpha into 0 plus sin alpha, that becomes cos square alpha plus sin square alpha, it becomes 1. Therefore your f of alpha inverse we can write, it is nothing but 1 by determinant of f of alpha into adjoint of f of alpha. So 1 by determinant becomes 1, adjoint of f of alpha is cos alpha 0 minus sin alpha 0 1 0 sin alpha 0 cos alpha. This is nothing but number 2. So from 1 and 2 your f of alpha inverse is nothing but f of minus alpha. It's very simple, easy question, right? And number 4, your if A is 5 3 minus 1 minus 2, you have to prove, so that a square minus 3a minus 7i2 equal to 0 2. Hence find A inverse. So how to find A inverse? We can use our pre-multiplying A inverse. So what will happen given A square minus 3a minus 7i2 is nothing but 0. This is nothing but 0. So how to find A square? How to find a square minus 3a minus 7i2? As usual, a square means you have to multiply it 2 times, and 3 into a you can find out, and 7 times i2. A square is a into a is 5, 3 minus 1 minus 2 into 5, 3 minus 1 minus 2. That becomes matrix multiplication 2 by 2 row into column. 25 minus 3 is first number. The second number will be 15 minus 6, and the second row first number is minus 5 plus 2, and this will be minus 3 plus 4. So that is nothing but 25 minus 23 is 22. 15 minus 6 is 9. 25 minus 3 is 22. 15 minus 6 is 9. Minus 5 plus 2 is minus 3. Minus 3 plus 4 is 1. So this is our a square, and 3a is 3 into your a value is 5, 3 minus 1 minus 2 is 15, 9 minus 3 minus 6, and 7 times i2 is 7 into 1 0 0 1. It becomes 7 0 0 7. So therefore a square minus 3a minus 7i2 is nothing but a square is 22, 9 minus 3 1 minus of 15, 9 minus 3 minus 6 minus of 7 0 0 7. So it becomes, first we will subtract these two matrix. 22 minus 15 is 7, 9 minus 9 is 0, minus 3 plus 3 is 0, and 1 plus 6 is 7, minus of 7 0 0 7. So it becomes 0. This is nothing but this one, right? So we found out a square minus 3a minus 7i2 becomes 0. The first part is over. The second part we have to find the inverse. To find a inverse with the using of the given equation, that is a square minus 3a minus 7i2 is 0. We can free multiplying a inverse. It becomes a inverse into a square minus 3 into a inverse into a minus 7 into a inverse into i2 becomes 0. So a inverse into a square becomes a minus 3 into a inverse into a becomes I minus 7 into a inverse into I2 is nothing but a inverse. It becomes 0. So a, you know, your a value is matrix 5, 3 minus 1 minus 2 minus 3 into your I value 1 0 0 1 minus 7 times a inverse we have to find. It is 5 minus 3 is 2. 3 minus 0 is 3. Minus 1 minus 0 is minus 1. Minus 2 minus 3 is minus 5. Minus of 7 times a inverse is equal to 0. We need a inverse, so we will take this one right side. It becomes